Good morning.
Good morning. Good morning. Good morning, everyone. Good morning. Got a few people still trying to connect, so we'll give them a second. All right. So looks like majority of everybody's in. So once again, good morning. Hope all is well. Hope everyone's doing all right. So today we're supposed to be starting chapter 3. And don't forget, let me see, I think the due date we put out there. Let me just confirm real quick. I think it's the 17th, if I'm not mistaken. Yeah. Okay. So, chapter two's content is due by the 17th. So just throwing that reminder out there. All right. So today, like I said, we get into chapter 3, starting off with 3.1 quadratic functions. Quadratic functions will give us a parabola when we graph it. And pretty much that's just a U shape. So it can be right side up or upside down. So when you say it's right side up, it's called concave up. When it's upside down, that's considered concave down. When your parabola is concave up, the lowest point on it would be the vertex. That's your minimum. When it's concave down, the highest point up would be your vertex, and that would be considered your maximum. The coordinates of your vertex will always be HK. Scroll up something. Okay, so the standard form of a quadratic equation, we have f of x is equal to a times x minus h squared plus k. So if a is greater than 0, in other words, if a is positive, then it opens up, it's concave up. If a is negative, a is less than 0, then it concaves down. It's concave down. Also, I was pointing out that HK, once again, is our vertex. Notice that you will use the sign for K, but you use the opposite sign for H. Notice we have that minus H in the formula. But when we talk about the actual ordered pair, it's just H. So you use the opposite sign of your H. All right, can I scroll up? All right, so the next thing is graphing quadratic functions with equation in standard form. So DET is determine concavity. So is A positive or negative? So we're talking about that letter A, where we just was talking about up here. So is A positive or negative? That will determine your concavity, whether it opens up or down. Determine your vertex, find x-intercepts, if any. Find your y-intercept. Plot the points 2 through 4, and then additional points as necessary. All right, can I scroll up? All right, so first first example under trying to do this, we have f of x is equal to -2 times x minus 3 squared plus 8. So it fits, our standard form. So we just go by the steps. First, we look at A. That's the number that's sitting in front of the parentheses. It's -2, so it means it opens down. Maybe if it's positive, it will open up. Vertex is going to be 3, 8. So remember what I mentioned before? You use the opposite sign for H. So if it's -3, then it should be +3. And then you use the sign that they have for K. So that's +8. Any problems with steps 1 or 2? Step 3, want to find the x-intercept. Find the x-intercept by letting y be equal to 0. So don't forget that characteristic of all of your x-intercepts, y is equal to 0. And don't forget also y is the same thing as f of x. So in this function, that's y, f of x is y. So we plug in 0 where f of x is. So I did right here. So that will give you, this. And so you would subtract 8 from both sides. That will put us here. Divide by -2. Divided by -2 will put us here at 4 equal to x minus 3 squared. Now we need to get the square off of x. So you take the square root of both sides. Don't forget the square root property whenever you take the square root of both sides to solve. Plus or minus goes on that other side with the square root and the square. It's not canceling off. All right, so square root of 4 is 2. So it's plus or minus 2. Then we add 3 to both sides. That'd be 3 plus or minus 2. And we can go ahead and add those together. 3 plus 2 is 5. 3 minus 2 is 1. Any questions? Any questions? All right. Next step, find your y-intercept. So if it's your y-intercept, you let x be equal to 0. So you plug in 0 for x. 0 minus 3 is negative 3. Negative 3 squared is 9. Negative 2 times 9, negative 18. Negative 18 plus 8, negative 10. And that is your ordered pair. 0, negative 2. Any problems? Scrolling up, and then if you graph those points, she'll get a rough sketch of your parabola. All right, any problems? All right, you scroll up. All right, so next thing, finding the vertex of a parabola whose equation is in the form of f of x squared plus b squared plus c. I said plus b squared ax squared plus bx plus c. So this is the form that we've dealt with. Oh, let's have my eraser up. That we had before. Just a regular quadratic equation. So saying that if it's not in the other form we just finished mentioning or using, where we could just pick out the vertex, we can use this relationship right here. H is going to be equal to negative b over 2a. Then if you take negative b over 2a, whatever that simplifies to, plug it into your function, that'll give you k. All right, so if we wanted to graph negative x squared minus 2x plus 1, a is still a. A is what's in front of x squared, so that still holds true as far as a being positive or negative. If it's positive, the parabola open upward. If it's negative, it opens down, no matter which form it's in. So we have -1, so it's open down, it opens down. Next, we can find the vertex. And don't forget, there is a minus sign in the formula, so make sure you don't lose it. So here, A is -1, B is -2. Oh, all right. So plug it in. That's -2 over 2 times -1. Then 2 over -2 will simplify to -1. So that's going to be H for us. Then you take that and plug it into your function. This is our function. So it's -1, or negative times -1 squared minus 2 times -1 plus 1. And then that simplifies to 2. So that means our vertex is -1, 2. All right, so x-intercept, let y be equal to 0, just like before. So -x squared minus 2x plus 1 equals 0. So this isn't factorable. So you can put it in the quadratic formula to solve. So that's -b plus or minus square root of b squared minus 4ac over 2a. So you plug in -2 for b, -1 for a, and 1 for c accordingly. It's -2 plus or minus the square root of -2 squared minus 4 times -1 times 1 over 2 times -1. So under the radical, that simplifies to 4 plus 4, which will give you 8. So now we have 2 plus or minus square root of 8 over negative 2. So I'll give you a chance to copy before I scroll all the way up. All right, so scrolling up, all we needed was points. So we didn't worry about writing the exact because we're talking about graphing. So we need the numerical value for it. So I just went ahead and converted it by using the calculator. So 2 plus square root of 8 over negative 2 gave me negative 2.4. 2 minus the square root of 8 over negative 2 gave me 0.4. Any problems? Any problems?
Okay, so when I square root 8, I could also break that down to 2 squared root 2, right?
Mm-hmm.
Okay, and then originally I just canceled out all the 2's, like I did 2, 2, and then the negative, and then I left negative 1 on the bottom. So it would just be square root of 2 over negative 1 as my answer, but that's wrong because I'm not plus or minusing.
Let me make sure that I got what you're saying. So when you simplify it, well, you said plus or minus, and so we're getting 2 different answers because of the plus or minus.
Right,
So
and I did it.
okay, so when you look at 2, you say you got 2 square root of 2 over negative 2, and so that negative 2 goes to each one. So if you reduce, that should be negative 1 minus square root of 2.
Oh, okay. I put the negative 1 on the bottom.
Okay. Yeah. Okay. So now, if you do leave it on the bottom, at some point you do have to take it up into each one of those numerators.
Oh, okay. All right. Thank you.
No problem. Or I will say this, or what you could do is if you leave it down bottom, that would be 1 plus root 2 over negative 1. If you simplify this first and then take the negative 1 up, you still should get this answer.
Okay. Thank you.
Yep, no problem. So yeah, that's most definitely what you would do. So as far as class, that's most definitely what you would do if you wanted to write the exact answer. Simplifying it to 1, plus square root of 2 would be, or 1 minus square root of 2, whatever it was that we just said. That would be the answer that we want. But since we're trying to graph, we're trying to get an approximate. That's why I didn't go that far. But if they ask you specifically what your answers are or what the intercepts would be, then that's what you would do. Yeah.
Okay.
All right. So next one, we let x be equal to 0 because finding our y-intercept. So you plug in 0 for x, and you get 0, 1. All right. So graph those points, and it will give us our parabola. All right, you scroll up, let me know if I'm wrong. I already mentioned this before, but they, this is just in writing and also giving you details of your vertex. So if x is greater than 0, in other words, it concaves up, your parabola concaves up, you have a minimum at the vertex. And we talked about how you can calculate your vertex by using negative b over 2a. And then if x concaves down, in other words, a is negative, I said x concaves down. If your parabola concaves down, in other words, a is negative, then it has a maximum at your vertex. And we talked about the coordinates there. So all right, so next exercise, consider f of x equal to negative 3x squared plus 6x minus 13. So determine whether it has a minimum or maximum value. So that's the first thing they're asking us. And so since a is negative, open down. So that means it has a maximum. If I don't have this here. Then it tells us to find the minimum or maximum, which is the vertex. So that's negative b over 2a. B is 6, so that'd be minus 6 or negative 6 over 2 times a, which is negative 3. Negative 6 over negative 6 is positive 1. Then plug 1 into our function. Negative 3 times 1 squared plus 6 times 1 minus 13 simplifies down to negative 10. So our coordinates for our vertex would be 1, negative 10. And scroll up. All right, so next one, identify the domain and range. Hold on 1 second. Sorry about that. So we want to identify the domain and range. So as we mentioned that our parabola is concave down. So we have our max, the highest value. So now your domain is going to go from left to right. So it's going to continue to get wider and wider and wider. So that would go from negative infinity to infinity. As far as our domain is concerned. So for all of these parabolas, your domain will always be negative infinity to infinity. So that will always be the case for you when it comes to the parabola. So now what will change is your range. So your range is always down to up. Your domain go from left to right. Your range is down to up. So it's always your lowest value to your highest value. So notice we have this maximum value. So that means we're coming from negative infinity up to this maximum value. So that's why we have it written this way, negative infinity to negative 10. And also we're looking at the y value. So we're not looking at the 1 in our coordinate right here. We're looking at the negative 10. And so that's how you do your domain and range. And then in the green circle, I was just saying if it opened upward and that was our minimum, our range would be negative 10 to infinity. So our lowest value would be negative 10 and it would go up. But once again, the domain would be the same, negative infinity to infinity. All right, questions on what we did there? All right, is everybody good? Everybody straight? That's it for 3-1. All right, so let's look at 3, 3, 2, 1, 2, 3 day. So this is what we'll do. Because we closed out 2-2 and we're looking to give you guys an opportunity to go ahead and finish that stuff out. This is where we'll stop today. Just do 3-1. Next class, we'll get into 3-3. Always skip 3-2. And if we have time, we'll double back and come to 3-2, but 3-3, more important, more of a flow. I think 3-2 is still just graphing or something like that. So we have time, we'll double back on 3-2. But 3-3 is where we'll go next. But we'll save that for next class. Any questions, concerns, comments before we close out? Everybody good? Everybody straight? All right. So you guys have a good one. Be safe. Have a great weekend. Take advantage of the time and make sure you get that chapter 2 stuff done so you can start focusing on chapter 3.
Thank you. Have a good one.
Thanks. You do the same. Take care.
You have a good
Have a
one.
good day.
Thanks. You do the same.
Bye.
Take care.
Have a good weekend.
Thanks. Appreciate it. You do the same.
Yeah, quick question, Mr. Tucker. When are you going to get all the grading done for chapter 1 and 2? Well, chapter 1 specifically, I guess, since now we're done with that completely.
When you say get the grading down, what you mean?
For example, like you said, like if you're gonna add the extra credit points to the test and all the homework finished and everything, you know?
Oh, okay. Yeah, I don't do that till final grading.
Okay.
Yeah.
I was just curious.
Yeah. So if you just want to know where you stand, you can always shoot me an email. I can let you know what I see and what your grade will be at this point. But yeah, as far as adding extra points and all the stuff like that, I do that at the final grading because Math Lab doesn't automatically do it, and I'll be shifting stuff all throughout the
all
semester.
Okay.
Yeah. So,
makes sense. All right.
But if you want to know where you stand, most definitely shoot me that email and I'll respond back to it and let you know what I see.
Okay. All right. Thank you.
All right, no problem, man. Have a good one.
You too.